All right, so this is a big lesson. Oh, it's important. This stuff has to be memorized. Go over it. All right. Let's see here. We have the product property of logs, and you can find all of these things on your form quizzes or your study sheets for your formula quizzes. And the product property of logarithms says that a log of A times a log, I actually wrote that wrong, sorry, I'm somewhere else. It says a log, and I'm just going to do two letters. A log that contains the elements A and B can be broken apart as log A plus log B. Now, that seems a little confusing, but logs are inverses of exponentials. We're actually talking about what's happening up in the numerator space. So I don't know if this will make any sense to you, but think about 2 squared times 2 squared. When we multiply terms down here, we add the exponential space. So it's basically this property right here, but done with logarithms. They're kind of opposite, so things happen in different places. The quotient property, I'll use a couple of letters on it. Log AB divided by CD. From log of A times B, we get what we already have, log of A plus log of B. But anything in the divisor becomes subtraction. Log C minus log D. And then you have the power property. The power property is a big one. If you have some logarithm out there with an argument and an exponent, which we call R, don't ask me why they call it R, the R gets shifted out front, R log A. And so that's where that one comes from. All right, moving forward, how can you use these properties of logarithms to expand each expression? So first I'm going to focus on the understood multiplier between a squared and b to the 7th. I'm going to have a log whose base is 5 of a squared plus log base 5 of b to the 7th. And that comes from that property about log of a times b, about breaking apart multiplication with addition. Now, the next property I'm going to use is the log of a to the r. It's r log a. So I'm going to take these exponents and I'm going to shift them to the front. So I'm going to have 2 log bases of 5 of a plus 7 log bases of 5 of b. So that was just a simple one. Some of these are difficult, some of these aren't. And here we have something that's invoking both multiplication and division. So there's a big note here. Division becomes subtraction. Now, I didn't explain why that one is the way it is, but say you had x to the 2nd. Actually, make that x to the 3rd over x to the 2nd. You would say that's x to the 3 minus 2. See how division is becoming subtraction based on an old property? It still works here. So let's do the break apart. Anything in the numerator, it's a bad looking log, is addition. And anything in the denominator is division. In fact, I'm going to type that out. So what I just said was anything in the numerator becomes addition. Anything in the denominator becomes subtraction. That's how this works. All right? Plain and simple. Always use that property that talks about r log a, or log of a to the r, becoming r logs of a. So this 3 gets to go out front. That 4 gets to go out front. 3 logs of base 7, argument r, plus 4 logs, and I forgot my little 7 there, didn't I? Base 7th of t and minus log base 7 of v, and v doesn't have anything other than the understood one. All right, and this is about expansion, not pushing the calculator. The natural log of 7 over 225 would be the natural log of 7 minus the natural log of 225. Now, it's a good place to show you that these properties are true because we have a number. So ln key 7 over 225 is this funky looking decimal. Well, guess what the natural log of 7 minus the natural log of 225 is? It's the same thing. Now, 60 years ago, you'd be looking at tables and stuff instead of pushing the buttons in the calculator. These properties would have been more useful as far as calculations go. They're still useful for solving. All right, so here we're going the other way. We're going to use all the same properties, and I am going to waste time writing them down. A log that contains the elements a and b is log a plus log b. A log that contains maybe a over b is log a minus log b. And a log that contains something with an exponent is r log a. Now we're going the other way around on these first. So we're actually going to start with these guys. If you'll look back, this was the last thing I did, right? I moved that exponent. So when I'm going the other way around, the first thing I'm going to do is I have to put these numbers there. So this becomes a log base 4 of n plus a log, of m to the 4th, sorry, plus a log base 4 of n cubed, and then minus a log base 4 of p. So I've got some addition. Addition is multiplication. I have a single logarithm, base 4. Inside is m to the 4th n cubed. Then I have subtraction, and subtraction is division. So over p. Not that bad. Move your exponents again. Natural log of 2 cubed minus the natural log of 5 squared. And I'm going to go ahead and figure out what 2 cubed is. This is the natural log of 8 minus the natural log of 25. And then I'm going to look at my subtraction operation. I'm going to realize that's division. So this is equal to the natural log of 8/25. Is it the same? It's a good one to see. Because you're probably like, I don't know about this, Milbrath. I don't know if this is true or not. That was 3 ln2 minus 2 ln5. And I said that was equivalent to the natural log of 8/25. By God, it was. Who would have thought? Okay, these are for you. And you should try. You should. You need to understand the notes. You need to be trying to figure these things out. We have an application, deals with the pH scale. Remember, the pH scale goes from 0 to 7. 0 is pure acid, 7 is pure basic. All right, pure alkaline. So the pH of a solution is measured as a measure of its concentration of hydrogen ions. This concentration measured in moles per liter is written as H plus and is given by the formula that pH is a logarithm of 1 over H plus, the 10 scale. What is the concentration of hydrogen ions in acid rain? Okay, so I'm going to take this 4.5 and I'm going to plug it in for pH. I'm going to write the understood. Remember this, a log of just an x has an understood base of 10. Remember that? You should write this. I wrote it, you should too. So there's an understood 10 here, and inside I have 1 over H plus. Now, what can I do with this thing? I can use log is base. So I'm doing these notes after 7th period left, and today was the easy day quiz. But I'm going to do my conversion. I'm going to figure out what my parts are. I know that this is my base, this is my argument, which means this is my exponent. And I'm going to plug into this right here. This is called exponentiating an equation. So I have a base of 10. My exponent is going to be 4.5, and I must equal 1 over h plus. Now, how do I solve an equation like this? I literally h plus both sides. And I would have h plus is, or sorry, not is, times, we're going for the times, 10 to the 4.5 is 1. Hopefully you have no issues with what I've done so far. I'm going to counteract multiplication through addition, through division. So h plus is, now remember this, whenever we deal with exponents, we shift things around. 10 to the negative 4.5. That is the hydrogen ion concentration. Funny looking number. It's like ridiculously close to 0, but there you go. That is the concentration of hydrogen ions in acid rain, which used to be a big deal when I was a kid. So this is for you. Again, you should try. You should. All right. Evaluate logarithmic expressions by changing the base. How can you use base 10 logarithms to evaluate base 2 logarithms? So there's a change of base formula, and here's one of them. There's actually 3 of them. A logarithm of base b argument a is equal to a logarithm of a over a logarithm of b. Now, I'm just saying straight up logs. That means 10 and 10. Okay? So I can rewrite this as log base 10 of 3, what's high stays high, over log base 2, or sorry, just log base 10 of 2. And I want you to remember that these 10s are understood. So when I go to my TI-84, I don't worry about the base. So I have log of 3 sitting pretty over log of 2. It's about 1.5850. Make sure you understand how I'm rounding. I keep telling you all this. 4th decimal. That 6 makes that round up. 1.5850. 4th decimal. Rounding. Somebody tells you to round in the 4th decimal, you include the position. All right, here's the 3 ways of rewriting a log. You have the one I just talked about. A log base b argument a is log base, screwed that up again, is a log of a over a log of b. Or, and these again, write these, study these. A log base b argument a is a natural log of a over a natural log of b. And this is probably my favorite. Or we can do what's called choosing a base, which I don't know how big a deal I'll make of that in Algebra 2. Log base c of a over log base c of b. And the c here is a chosen base. Something you choose. Something you choose. It can be anything in the world. Estimate the value of each logarithm, then use a calculator to find the value of each logarithm to the nearest 10th. So, what they're asking here is for you to try to figure out on your own. They're saying what power of 2 equals 7. I would think it would be a little less than 3, because 2 cubed is 8. So how do I use a calculator? So this is a big deal. You should be writing this. I like ln. I'm going to do ln 7 over ln 2. I really like the ln keys. ln 7 over ln 2. What's high stays high. What's low stays low. You're probably listening to me muted, or you're copying somebody else's notes. So you're not hearing anything I have to say. Shame on you. It's about 2.8074. By the way, you should get a calculator from the library. A log base 3 of 5. Now say you don't like my ln technique. This is what power of 5 equals 3. Now I know 5 to the first is, by the way, remember, see how close that was? 2.8. 5 to the first is 5, so it's a little less than 1. Maybe it's like 0.83. I have no idea what it is. But let's just do the plain old log. Most kids, like see a log, they just like to write log. Log 3 over log 5. Log 3 sitting pretty over log 5. Point out is off, 0.6826. So there you go. Moving forward, using the change of base, and I left this one for you. This is for you. What is the solution of the equation 2 to the x equals 7? Express the solution as a logarithm and then evaluate around the nearest tenth. So we have 2 to the x equals 7. We identify our pieces. This is my base. That dude is my exponent, which means that this must be my answer. All right. I have what's called a logarithm now, because I got to write this down because y'all don't know it. A logarithm base b argument a equals e is equivalent to a base with an exponent and an answer. So that's why I did this. And again, write this. Log is bay. Doesn't get any easier. I have a logarithm base 2. My argument is 7, and that would be my x value. All right. Now, I don't have a log base 2 button on the calculator, so I got to do change of base. And I like ln. ln 7 over ln 2 is x. This is the kind of answer I like to see. You might also write ln of 7. No, I actually can't do anything with that. I'm being stupid. Forgive me. Just push buttons in the calculator. ln 7 divided by ln 2. It's about 2.8074 because we did this one earlier. It's about 2.8704. See how we did this earlier? Did it right there. All right, and you guys get to do that one. And that is it for this set of notes. It was a quick video, I think. Oh, it was 18 minutes. It felt like less time than that.